Let's start by looking at a fairly simple example of multiple indirection. Here I declare an array to store 3 integers, where length equals 3. This loop puts some values into the array, 0, 1 and 2. And this loop just prints those values for me to check that everything's correct. Now let's see how I can access those values using both simple indirection, that is, using a pointer to an integer, and multiple indirection, using a pointer to an integer. I warn you in advance that, simple as this may seem, you'll probably need to stare at this quite a while in order to understand what's going on. Here are my 2 pointer variables, pi, which is a pointer, as the asterisk shows, to an int, and ppi, which, as it's declared with 2 asterisks, or stars, is a pointer to an int. Data is an array of integers. As we know, an array is an address. It's the place in memory where a list of data items begins. So I can simply assign that address, that array variable data, to my pointer variable pi. Now I assign the address of pi using the ampersand address of operator to my variable ppi. So pi is a pointer which points to the data array, and ppi points to the pointer pi. Now this loop iterates from 0 to 1 less than the length of the array. That is, the loop runs only while I is less than length. In other words, from 0 to 2. And it prints out various bits of information which we'll look at shortly. At each turn through the loop, the pointer is advanced to the next element in the array by adding 1 to the pointer variable pi. This is a simple example of pointer arithmetic which will be explained later in the course. Now let's look at these printf statements. Before we do that, let me run the program and see the results. So you can see the first printf statement prints the array address. The %p format specifier is used to print an address as a hexadecimal value. The array address never changes, of course, so we see the same number at each turn through the loop. Next, we dereference the int pointer, pi, to display the integer at each index of the array. At the first turn through the loop, pi points to the start of the array, and the first element, 0, is displayed. In subsequent turns through the loop, the other integers which we added to the array, 1 and 2, are shown. And now we display the item pointed to by ppi. Recall that ppi is a pointer that points to another pointer, pi. We assigned the data array to pi. So remember that an array is an address, and at the first turn through the loop, we dereference ppi to get the value stored at whatever it points to. It points to the pointer variable pi, and that is the address of the data array. So you can see that ppi points to pi, which points to the array. The address of the array is shown here, so that when we dereference ppi, we get the address of the array stored in the pointer pi. In order to go further and get the value pointed to by the pointer pi, we need to use this double indirection operator, **ppi. That says, get the value of what is pointed to by the pointer that ppi points to. So ppi points to the pointer pi, and pi points to an int. So **ppi gets the value of the int pointed to by pi. At each turn through the loop, pi is incremented to point to the next element of the array, and when we use double indirection **ppi, that returns the value pointed to by pi, which is the next integer in the array. Now, I know this can be hard to follow, so let's look at this final printf statement. This displays the address of the integer pointer variable pi and the value of the pointer variable ppi. So when you run it, you can see that the numbers are the same, and they stay the same. That shows that the value stored by the ppi variable is the address of the pi variable. In this program, that address never changes. So the value of ppi is the address of the thing it points to. It points to pi, and pi points to an int. So one level of indirection, star ppi, gets the value of the pointer pi, which here happens to be the address of an integer. Two levels of indirection, star star ppi, gets the value of pi, that is, the data stored at the address pointed to by pi. And in this program, that's the integer 0, 1 or 2 at that address. Let's finally add one more line to clarify this, I hope, even further. I'll just copy and paste this in for speed. Save it and run it again. Now this line prints the value of the int pointer pi, which is an address, and by indirection star pi. So there we get the integer that's stored at that address. The address of pi is incremented at the end of the loop, so the number shown changes on each pass through the loop. The value pointed to also changes. But if you look back here in the printf, where we used 2 stars before the ppi variable, that is 2 levels of indirection, the value returned is the same value which we got when using 1 level of indirection with the pi variable here. And that's because ppi points to pi. So 1 level of indirection goes to pi, and the second level of indirection goes to the integer to which pi points. Yes, I really know that this stuff can be really hard to get to grips with, especially if you've never used pointers or multiple indirection before. And you may need to try out this code sample or write your own, and maybe use a debugger to step through it one line at a time. It really is worth the effort though. Once you can understand this, you'll have crossed one of the major barriers to understanding how pointers really work.